Hello GameMakers, this is GameMaker Rob, and in today's episode we finally have some working AI. Actors will now heal themselves, heal their allies, attack the weakest enemy with the strongest weapon, or just simply move towards the nearest target if there's nothing else they can do. So let's get started. Okie doke, so the first thing we're going to do is we are going to make two scripts so we can reuse the same code for the AI as well as the player. The first script is going to be called scr_facing, and the code is very similar from the step event of OBJ test. We're just basically checking which facing the current actor should have based on a target grid X and target grid Y. So make sure you've got this. And then the other one, the other script we're going to make is scr_remove_if_consumable. Basically, is the item they've just used a one-shot item? If it is, get rid of it. Again, the code is very similar to the code from the step of OBJ test, and we're going to be updating that step event now. So if we go into OBJ test and step, and we're going to do a search for scr facing. So we're in the perform attack spell or item region, which is in pressed enter after already choosing a menu option. So we're in taking action, pressed enter after already choosing a menu option, and then perform attack spell item. So, and then in this region here, so this was the previous code. We don't need it anymore because we're just going to be having this line here, setting the actors facing to whatever this script returns. And then the other one, scr remove if. So this region we're in awaiting action and pressed enter, so we're in actor taking turn, picking action from the menu, awaiting action and pressed enter. So this was our code before for selecting an item. We don't need it. We just want this line instead. Just run this script. Okay, so the next thing we're going to do is in scr action calculation. We've got a line here where we set roll to 100. This was to make sure that every attack was a miss to test it. I don't know if you have it. You may or may not. But if you do, just make sure it's commented out because it's going to make the AI miss every attack. So we don't really want it. And then in the step of OBJ actor, so here we were clearing the list of active nodes, and that was fine because we didn't want to see the nodes on the screen. But because of how the AI works, we still need the list to contain nodes after the AI is finished moving. So we want to comment this out for now. Well, we're not going to use it here anymore. And as a temporary fix, just so we don't always display nodes, if we go into the OBJ test, and then in the next actor region, this line here, I've just added that basically. Okay, so how will the AI work? In the next actor region of OBJ test, we're going to check to see if the current actor is AI controlled. If it is, then we are going to change to a new battle state called AI controlled. In this new state, OBJ_AI manager is created, which listens for cues so it can direct the flow of the turn. E.g., if the current actor has finished moving, the game will want to know the new facing. and the AI manager will be listening for this and act appropriately. The AI manager will also have two states where it's either getting the next action for the AI to take from a priority queue, just like OBJ animation does, or it's waiting for the animation to finish. If there are no more actions to take, OBJ AI manager will destroy itself. If there is an action that the AI wants to take, the AI manager's job is to create and set up any necessary variables for OBJ animation, which then takes over and runs the same code as it would for a player-controlled actor. To decide what action to take when the battle state is first switched to AI controlled, we run a script that determines the action taken with certain priorities. These priorities are healing self or friendlies with the most powerful healing item, attacking the most wounded enemy with the most powerful item, finally move towards the nearest enemy. The AI will also take into account the min or max range of its items, and where they're moving will help take the actor into the min-max range to be able to use the item on the target. Okay, so now if we go into the create event of OBJ test, we just have one new enumerator for eBattle, and it's going to be called AI controlled. And then in the step event of OBJ test, it's in setup battle, create an instance for this unit. So we're in create an instance for this unit. We had a variable called player controlled, but we were setting it as is AI controlled. So if it didn't make sense, basically, so I've renamed it to AI controlled like this, and we can now actually use it as well. So if we go into in battle, then next actor, and here, so we want to check to see if a character is AI controlled. It doesn't matter if the character is in the player's team or not. The AI is going to work the same. It's going to heal its allies, whether the ally is player controlled or an enemy. It's going to attack the enemies of the team that it's on. So regardless of the team, is the actor AI controlled? If not, then the player is going to take control. Otherwise, the AI is going to take control. Okay, so because we have a new enumerator, we're going to have a new region. Let me just minimize this. So we have this new region here. If the battle state is eBattle.ai controlled, then we want to check to see if an instance of AI manager exists. If it doesn't, we want to let ourselves know we're making an instance of the manager. You don't have to have these debugs, but let me just space them out so it's more readable. So create the AI manager. Tell the AI manager that its queue is going to be based on what this new script returns. The new script is scr_AI_actions. Just type this line for now. I know that you don't have the script. We're going to make that next. And then we only want this to run once. So we're going to change the battle state to running action just to prevent that. And that's it. That's all the changes to the step event. One last thing. OBJ test draw. We want to be where it says draw current actor if moving inside the battle unit region. So all I've done is I've commented out this line which checks for the battle state. I've just checked if we just changed it so to check if the current actor is not no one and they're moving. This is because excuse me, because the battle state isn't going to equal this on the AI turn. It's not going to draw the current actor, so that's why I've cut it out. So this is all you need. Okay, so if you make a new object, call it obj underscore capital A capital I underscore manager. So it's the AI manager. And in the create event, we're going to have 3 variables. The first one's going to be a state, which is get next action. This is the same enumerator that we use for the animation object. Timer is going to give us a pause between things like choosing facing or taking the next action. Target is who are we going to be facing to change our facing to, if that makes sense. Okay, so now if we go to the create a step event for this new object, and just to get this basic structure typed out for now. So for this first region, we want to check to see if the state of our manager is get next action, and also that the current actor isn't moving. So as long as both of those conditions are true, then we're going to run the get next action region. First thing we want to do is say, okay, is the size of our action queue greater than 0? Is there something else for us to do? If there isn't, then we can just get rid of our AI manager, destroy it, and tell the test object to just get the next actor, because this current actor is done with their turn. What's more likely though is that there is actually an action to take. In the queue, it's going to have a list. The list is just going to say, okay, what item is being used and what is the current action. Is it spell item or attack? That's all we need to do, really. That's all we need to send to the manager. So as long as it's not move, then we are going to make an animation object, like here. You don't have to have these show debugs. If you want me to help you out with your projects when they don't work, though, these are useful for me, so just bear that in mind. So we want to tell our test object, we want to set its current action to action. This is because it's going to be checked by the animation object, so we need everything to be the same as it would normally be if the player was making their turn. So after we've done that, make the animation object, tell the animation object its new state and what item is being used. Afterwards, we're going to set the state of our animation object to wait for the animation to end. However, if this was the last action, which it quite often is, then we just get rid of the AI manager anyway. So that's what happens most of the time, because we only send one action to the queue. So that's this first region done. Then in wait for animation end, this was a placeholder. We don't need to do anything if animation object exists, because it handles everything itself. If there isn't instance of obj animation, we just want to check to see, okay, is obj test wanting us to choose the facing for the character? So if it does, then run the timer. However, on the very first step, if there's a target, we want to change the actor's facing first. So what will happen is the actor will move, change their facing, the timer will run. After a second, then we're going to set the current action of obj test to awaiting action, and then set the state of this object to get next action. So, and that's how this is all the manager does. It just waits to see, do we need to change the facing of an actor, and do we need to create an instance of the manager, and just update the variables. That's all it does. Okay, so make a new script and call it scr underscore capital A capital I underscore actions. This is going to basically determine what an AI actor should do based on a priority. The priority is healing itself and allies first, and it will use the healing item, whether it's a spell or a consumable, whatever, or even a weapon, it will use the item that will heal the most. If it's attacking, it will choose the weapon that will damage the most, and it will pick the enemy that is the most wounded. So we have a queue of items that can heal, and we check before we go into attacking. We check to see if any of these items can be used on any of the actors, and we should end up with the most wounded character being healed by the most powerful healing item. That's how it should work in general. And the same with attacking. The most damaging weapon is picked first, and then all the enemies are checked to see if we can get in range to attack them, and then the next powerful weapon is checked, and so on. So if we end up in an instance where there's nobody to heal and there's nobody to attack, then the AI will just move towards the nearest enemy. So there is, I think I said it before, there's a huge scope for adding new checks. You know, if you want the AI to do different things based on its class or stuff like that. But I didn't want to go too full in depth into it because it's already quite a bit of code just for these three main priorities. But I also think this is something you can build on. So that's what this comment's about. It's just kind of saying, okay, what order should we check things off? Although I didn't implement the check to see if the character was less than 25% health. I think I changed it in the end. Anyway, so we passed to AI actions, the current actor, list of battle menu lists, and the movement range of the actor. We want to use battle menu lists because we want to check every item that the character has equipped. So we want an enemies and an injured list as well. Enemies will just hold all the IDs of any enemies on the field, and injured will hold a list of any injured on the field. Let me just check as well. Check to make sure. I can't remember if I did a check to see if the actors are alive or not. So let's check that as we go. And AI action queue is going to hold a list that we send to the manager, or nothing. So in the healing region, we want to make a list of all friendlies below a certain health range. We don't check. We're not checking if they're alive, so let's add that here as well. If AI stats. Okay. Yeah. Otherwise, we'll be adding dead players to the team. Basically, so for healing, we want to check to see if the actor is on the player's team. So if this current actor's in player's team is the same as the current actors in player's team, then they're on the same team. And also, if the HP is above 0, then also check to see whether the character has less than 75% of its health. If it does, then add this actor to our injured list. After we've done all this, we need to check to see if there are any injured people. If there isn't, then there's no point doing the rest of this, and we just continue to the next region. But if there are people to check, then we want to make a queue of all the items that can heal, with the most potent healing item having the highest priority. So make a priority queue here. This double for loop will go through all of our battle lists to see if we have any items that we can use. So we want to check to see if the stat affected is HP. we want to check to see if the value affected is greater than 0, because positive will heal, negative will damage. We also need to see if the current actor has enough mana to use the item as well. So if all of these checks come back true, then we're going to add the healing item to the item queue with a priority of its range. That shouldn't be right. Let's do priority of value affected. There we go. I was originally going to do stuff based on AoE, but there would be quite a few extra checks to do for AoE, so I've just left it at this for now. So total healing items is going to hold the size of our healing items queue. If there aren't any healing items, then we don't need to do this. However, if there are, then we want to run another script called SCR targeting range. This script is going to check to see if any of the targets are in range of any of the items. We're going to use this script for both healing and for attack because the code logic is the same. You know, am I in range to use this item on this person? We're going to code this script last, so don't worry about any yellow marks you get for now. Can make action is going to return true or false. If true, then we have found someone in this list that we can use one of these items on, and we will have a list created inside this script that will be added to our queue, and then our SCR AI actions script is going to return that queue to the AI manager so he knows what to do. And then whenever you call return in the script, the whole script is done. So if this returned false, however, then we go on to the attack region. The attack region is very similar. So create a queue of offensive items. We want to do a double for loop through all of the items to check to see if any of the items have a value affected of less than 0, because that's a damaging item. If the size of the queue is greater than 0, then it means we have found... Oh, let me just explain something as well. Because we're using the same script, SCR targeting range, to check to see the most potent item, we need to add the priority of defensive items as their absolute value, because they should all be negative numbers, but we want the positive ones. So minus 50 is going to be 50, etc. That's the only really major change in this double for loop compared to the healing one. Okay, so if the size of the queue is greater than 0, then again with OBD actor, let's first of all check that they are not in the same team as the current actor, and also if estats.hp current is greater than 0. So basically, if they're not dead and they are not in the current player's team, then add this actor to the enemies list. If there are any enemies on the field, there should be, if this is running. Well, actually, yeah, there should be. Then, again, run our script targeting range. And this is going to return true or false. If true, then we're done with this script. The AI has found someone to attack. Otherwise, we're going to go on to move towards nearest enemy. Okay, so move towards nearest enemy. The way I decided to do this is whoever is nearer based on the grid coordinates, we're going to say that's the nearest enemy. It may not always be the nearest enemy because it doesn't take into account a path to get there, but it's a very simple check to do, and it has little to no overhead. A more precise way would be to check a path to every single actor or something like that, every single enemy, and then compare, okay, which is the shortest path. But for this tutorial, for now, I thought this was a simple method, that works. So we have 3 parts to it. So find nearest probable enemy. We're going to destroy the list of enemies and use the same name to make a queue of enemies. We're going to add any actors that are an enemy to this queue based on their distance, with the lower value being the one that we want, the lowest value. Distance is going to be the difference between the actors grid X and the current actors grid X, and the actors grid Y versus the current actors grid Y. So after we've created the queue, after checking all the actors, then our target is going to be the one with the lowest distance, and we can get rid of the queue because that's all we need it for, really. If we wanted to do a more precise check, we'd have to go through all of the priority queue, create a path to each one, and then based on the size of the path, go for the one with the lowest path. The more I talk about it, the easier I think it'll be to do, but maybe that's going to be another day. Okay, so if we have a target, then we're going to do this stuff. So if target is not equal to no one, okay, so when we have a target, we want to have a path that the current actor can follow. Normally the player will just click on a square, and that's where we know where we need to move to, but where we're trying to get to now is the target. If we are this far, then it means there's no target in range, so we have to make a path, however long it is, to get to the nearest enemy. Once we made that path, we have to reduce it in size so that there's only as many path points as the actor can move. So that's what this is for. So we're going to fill our list with nodes so we can get from the start node to the end node, and then we're going to use our generate path script to generate a path of the nodes that will give us the best path from the start to the end node. This could be like 20 or 30 nodes long, and in our tutorial our movement points are only 4. So then we're going to have this loop here where it says while the size of the queue is greater than or equal to our movement points, just delete the next node from the queue, and that will give us a path we can actually follow for our movement. And then this last region here, make the actor move. So tell the current actor it's moving, it has moved, and target node is this one here. All this stuff is very similar to the stuff inside OBJ test, but we also have to tell the test object the current action is a move, and our manager object tell its state to wait for the next animation to end, and also tell our manager what target it is. Okay, last of all, we need to create SCR underscore target underscore in underscore range. Basically, this script checks every item that we want to check to see if any of the actors are in range of the item before we go to the next item, and then when we run out of items, if it hasn't found any actors that we can use the item on, then the script returns false. Otherwise, it will return true after filling a list with the item that's going to be used and the action that's going to be taken. So I think this is pretty self-explanatory. So for as many items as we have, get the item with a maximum priority. We want to know the range of the item, the min and max range. Don't forget, if you have a bow, you have to be 2 spaces away. You can't be adjacent to use it, so you have to check for that as well. Then our second for loop is going to go through our whole list of actors for every item until it finds an actor, if it finds an actor. So get the next actor. Distance of target is going to be based on where the target is compared to the actor. So that's what this calculation is going to do. So how far away as a number in terms of adjacent cells is the target away from the actor, current actor, sorry. So the first check we're going to do, if the distance of the target from the current actor is greater than or equal to the min range and less than or equal to the max range, then the current actor doesn't have to move to attack the target because the target's already within the min and max range. So we can just queue up an attack basically. So remove any mana cost of the item from the current actor. Use our remove if consumable script to check if it's an item as well. We also want to update our list of active nodes with the AoE nodes because the animation object is going to use that. So this stuff is what we've done before for the AoE. And then this list here is the one that gets added to the queue. So we add the item that's going to be used and the item type. And then we add that list to the action queue and then return true. So that means none of the rest of the script will happen. And that's it for this region. Okay, so all this is doing is saying, okay, if we move, is that going to take us to within the range that we need to be? If it does, then we need to do 2 things. We're going to have to tell the current actor to move, and then we're going to have to queue up the action like we did in this region. This script is going to give us a list of all the nodes we can move to. We're going to check each of these nodes in turn to see if that node is going to get us to the point where we can attack the target. So as long as the size of the list of active nodes is greater than 0, we're going to find the target score of the target. So that's just basically what are their grid coordinates. And we're going to compare the target grid coordinates with the node's grid coordinates. If the difference of the node score and the target score is greater than the min range and less than max range, that means that we can move to this node and we can be within range of the item we want to use. So if this is true, then we found a node we can use. So the first thing we want to do, like I said, is make the actor move. I probably could have put this in. I didn't want to have too many scripts because this is the same code as before, but just make sure you've got that down. And then queue up an action. Again, this is the same code as before, just with lots of debug messages. I've already gone through all of this stuff before, and that's it really. If we get down to this line here, let me just minimize this stuff. So if we get down to here, then it means we've gone through all of the items and all of the actors for all the items, and we haven't found a target within the range. So return false, and that will tell I'll tell our AI script, okay, so there's no one to heal, and then I'll do the script again. If the script returns false, okay, there's no one to attack, so then we're just going to move, which is our last action here. It'll just move. So these 2 regions will use SCR target and range to find someone in range. if both of these return false, then it gets to this one here. This should always run. All we need to do now is test it, really. So if you run the game, and then so the enemy's taking their turn. There is no one to heal, no one to attack, so we just move forward. I'm going to move just this guy forwards. And that last guy, you can see he turned to face the nearest enemy, which is this character there. And I think the archers, the guys with blue, are going to be in range of an attack soon. Let's move this guy forward again. So the archer's going to attack and does 12 damage. The second archer's going to attack, just 12 damage. I killed him. Butts is dead. Did he only have 24 health? The reason we lost the game is because Butts was a mandatory character. If you lose a mandatory character, then the game's over. Let's just check the health that Butts has. Let's give him some greater health. Oh yeah, let's give him 999 HP. There we go. Let's run the game again. I'm just going to play through and speed it up to save time. Okay, so let's just check that the AI will heal itself as well. So if we're going to OBJ test, end step, and then set up battle. And here, in the created instance for this unit, I've got this line in the created instance for this unit, and all it will do is reduce everyone's health by 60%. So if we run the game, and then the first guy goes to heal his friend, the alignment of the text is off a bit there, and he heals himself. The guy who got healed heals his friend. They're all using their healing pots, I think. So they will all heal themselves because that's what they're supposed to do. And now they should move towards this character. And he'll probably die to archers again. For some reason the AI isn't attacking, so let me just try and fix this now. I had a strange bug. It wasn't strange, it was just stupid really. Basically where the AI, after taking an action once, wouldn't do much apart from move on any subsequent turns. And the fix for that is basically getting rid of the lists and the queues, and all we need to do is inside SCR target and range. If in this region here we just want to destroy the queue and the list, and we should be good. Let's put this here as well, just to be doubly safe. Okay, cool. So let's run the game again. I've got the game started off where everyone has 40% of their existing health. So we should see all the AI heal. And then kill one of my characters. And the last thing I want to do really is just give my player characters a lot of health, so we can see some melee attacks happening. That's the only thing I haven't really tested yet. Oh. There we go. Let's run the game. Okay, I think I'll leave it there. I can see a couple of bugs, small things I need to fix. For example, the health is a decimal place now, and also the very first attack seems to have the alignment of the text is wrong. And I've not been able to test any melee because for some reason they've all got ranged or spells. So I'll have to test that between now and the next episode. But I'm really pleased to have actually got the AI to this level, because it was fairly challenging and a lot harder than I thought it would be. But I'm just glad to have this in the game now. So I hope you enjoyed the episode, and I will catch you next time. Bye for now.